So in this video, you'll be able to understand the derivation with respect to how a series frequency is equal to geometric mean of two half power frequencies. That is omega naught, omega r or omega naught is equal to square root of omega 1 plus omega 1 into omega 2, or fr is equal to square root of f1 into f2. So show that resonance frequency of a series resonance circuit is equal to geometric mean of two half power frequencies. So we have seen in the earlier videos, impedance at f1 or omega 1, right? We have the impedance z1 as square root of r square plus xc1 minus xl1 the whole square, and then for f2 it is z2 r square root of r square plus xl2 minus xc2 the whole square. Now I hope you are aware in the previous videos that at f we know the resonance that is f or f naught or fr is z is equal to r, and we have seen in earlier videos that as we increase frequency, xc is increasing in nature before resonance, right? So in this video here, in the last couple of videos, we have seen that at lower frequencies xc is greater, so that's why the impedance for z1 at f1 we can see xc minus xl, and similarly at f0 the impedance z is equal to r, and as we increase the frequency further beyond resonance frequency, xl is greater than xc. So I hope now it is clear at z1 why xc is greater than xl, why we have taken x positive, and at f2 why we have taken xl positive, because at f1 at lower frequencies, that is below resonance frequency, xc is greater, that is 1 by omega naught into c. So at resonance we know that z1 is equal to z2, so substituting them here, and square root cancels each other, rearranging the equations. So as we are aware that r square would cancel each other, as this r square moves towards LHS, it becomes negative and they cancel each other, and cancelling the squares we have left out with xc1 minus xl1 is equal to xl2 minus xc2. Then rearranging for capacitance and reactance, and just writing them in terms of omega. So xc1 is 1 by omega 1 c, and xc2 is equal to 1 by omega 2 c. So you have to see that this xc1 is at f1. So at f1 omega 1 is nothing but 2 pi f1, right? And omega 2 is nothing but 2 pi f2, right? So taking the constant outside, so we've taken 1 by c as constant outside and L outside, rearranging them again, and here if you move this omega 1 plus omega 2 at the bottom, they cancel each other, thus this is a reduced equation, and 1 by LC is equal to omega 1 into omega c, and we know at resonance omega r or omega naught is equal to 1 by root of LC, or omega square or omega naught square is equal to 1 by LC. Thus substituting that in this place, we get this as omega r square is equal to omega 1 into omega 2, or simply omega r is equal to square root of omega 1 into omega 2, or we can simply write fr is equal to square root of f1 into f2. So this is how you have to derive when a question is asked with respect to a resonance frequency, that is a series resonance frequency. It is equal to geometric mean of two half power frequencies. So thank you for watching the video. Please do subscribe the channel to enhance your knowledge further.